So with filler metals for submerged arc welding, we can get a lot of different chemical compositions in the weld deposit by changing the flux. And they do that by putting different elements into either the filler metal or the flux. So if we needed chrome, nickel, molybdenum, or magnesium into our weld metal, they could put things into the flux or the filler metal that would give us a lot of different combinations that we can't really achieve with other welding filler materials. And this classification, like I said in an earlier slide, it boils down to the chemical compositions of the electrodes and the fluxes and impact strengths, and it's kind of a complicated system, but just know that it does exist, and if you need to go down that rabbit hole, there's information there. Generally, the flux is classified on the basis of the mechanical properties of the weld deposit made with a particular electrode. So not, it isn't base material or filler material A and flux A are always used. Sometimes you can use filler material A and flux B or flux C or flux D, and it's going to give you different mechanical properties on your weld joint. So that's one of the advantages of submerged arc welding. It gives you a lot of different combinations as far as mechanical properties of the weld material that's being placed in the weld joint. The electrode flux combinations can be really varied. And if you're doing this kind of welding, you really not got to be on top of your game. You've got to understand the process and have control over it. If in your shop you've got multiple fluxes and multiple types of wires being used, you need to make sure that your welding personnel know exactly what they're doing and understand that they can't just mix and match. Some advantages: high deposition rates. When you really got to weld something, a thick material, this is the material to do it with. This is the welding process to do it with. No flash or glare. You don't have to wear a hood when using this process. Not a lot of smoke and fumes with this process. It's actually a pretty clean process in regards to fume and smoke generation. There's a little bit, but it ain't very much. It's not like flux core arc welding, the self-shielded process that kicks off a lot of smoke. So the flux and wire being added separately, that gives you a little bit of extra control in regards to your, control of, your mechanical properties. Easily automated. This is a very rarely will you see this as a handheld process. This is an automated process. So generally we turn things in a circle and use this process and just put down a lot of weld metal into a weld joint. We can do narrow grooves with this because it's just running with a lot of current, and there's narrow groove options that we probably can't get with other welding processes. We can do carbon steels, low alloy, stainless, chrome moly, nickel, whatever. There's a large variety of materials that can be welded with this welding process, with submerged arc welding. Limitations: the flux, we can't view the weld joint during welding. So if you need to see what's going on in there, this is probably not your welding process. Flux can get contaminated if we don't keep it in ovens and we don't, keep people from throwing cigarettes or garbage in there or whatever. Flux can become contaminated, and that can lead to porosity in our weld joints, and then you got to cut them out. And I had a guy tell me years ago that one guy with the submerged arc welding, if he does it bad, can create enough rework to keep 5 guys busy for a week. So something to think about. Not suitable for thin material. We generally don't weld submerged arc welding with sheet metal. There's other processes that are better for that. Submerged arc welding is for really big welds where we got to deposit a lot of weld metal into a weld joint, where we need high deposition rates. We can't weld in anything but the flat position with this flat and horizontal fillets. And horizontal fillets are pretty much flat. So you can't use anything but the flat. If we need to weld something going uphill or out of position, we're not going to be able to get that accomplished with this welding process. Slag removal. We got to remove slag. Generally, the slag isn't as bad as stick welding, shielded metal arc welding, but the slag removal, the slag is pretty, it usually peels off, but you do have to deal with it. And you do have to run a wire wheel over the weld generally after you've made a weld with this welding process. And you got to deal with flux handling equipment. You know, you got to have ovens and places to store it, and then you got to carry it in buckets and keep it heated and put it in the hoppers and then deal with it when you're done welding. You got to take all that flux out and go put it back in an oven so it doesn't get contaminated with moisture or whatever. So flux, dealing with the flux, big 3-5 gallon buckets, you know, what would that be? 10, 15 liter buckets of flux can be problematic. And it's not problematic, but it's just time consuming. So in summary, submerged arc welding, a lot of wire flux combinations. The equipment is really high cost, but we get high deposition rates. The consumables are low cost. And once again, it's got nothing to do with welding underwater. Questions, comments, thoughts, concerns, you can contact me or the other instructor, Ray, through the Udemy website. You got any questions, we'd be happy to hear from you.